So again, it's a question right out of our textbook, as always. Alrighty. Let's see. It says predict the products for each of the following Diels-Alder reactions. Well, the first thing I notice about A is that we have a cyclic diene. So that means we're going to form a bicyclic compound. So our compound is going to be bicyclic. And I also notice I have a trans alkene as my dienophile. Therefore, when I draw the bicyclic compound, one of these carboxyl groups will be in the endo position and the other one will be in the exo position. So let's start by drawing the bicyclic product. Now keep in mind, this isn't going to be not going to be a 5-membered ring and a 6-membered ring. Not in this case, it's going to be 2 6-membered rings because we have 2 methylenes in this bridge. So we're going to start by drawing a 6-membered ring. It's not very pretty. It should look something like this. There's our first 6-membered ring. We're going to have a pi bond here. And then our second 6-membered ring would look something like that. Again, not the prettiest drawing in the world, but you get the idea. So let me just move this a little bit. There we go, like that. So one of our carboxyl groups is going to be in the endo position. So we'll put that down here. And the other one is going to be in the exo position. And then I'm also going to end up with the enantiomer, aren't I? Because I could orient this dienophile one of 2 ways. So I'll also end up with the enantiomer in this specific case. There we go. And if you need some practice on your curved arrows, it's the same 3 curved arrows as before, like that. Next, we have cyclopentadiene, and we have an unsymmetrical dienophile. However, our diene is symmetric, and so we don't have to worry about regioselectivity. But we have a cis alkene in this case, right? Both of our H's are on the same side. So this is a cis alkene, or you could call it a Z alkene. And so we're going to end up with both the carboxyl and the nitrile in the endo position. So let's draw the bicyclic product, which is going to look like this, where we have our 5-membered ring, put our pi bond here, and we're going to have our 6-membered ring, and both the carboxyl is going to be down here, like this, and the nitrile is going to be down here. Now, of course, the same thing applies. We could end up with the mirror image of this as well. So we're going to have to write plus the enantiomer in this case. Well, the next one, I'm kind of running out of space here, so I'm going to switch over to a blank document. So this is 16.42C. So just bear with me to find us some space to do this problem. Here we go. So we're at 16.42C. And the way that they've drawn the diene is they've drawn it in an S-trans conformation. I'm just going to save myself a little bit of time, and I'm going to draw it in the S-cis conformation, like this, where I have the double bond here and the double bond here. Again, this is the S-cis conformation. And again, in the question, they drew it in the S-trans conformation, but I just rotated the bond to make the S-cis. Now we're going to draw the dienophile, which is a trans or an E dienophile. Now in this case, I'm not going to form a bicyclic product. I'm going to form a cyclohexene derivative. That means that one of the acyl groups will be going up and the other one will be going down. And I will form the enantiomer as well. Let's draw our curved arrows for our Diels-Alder reaction. It's not very pretty. It should look something like this. There we go. Let's draw our 6-membered ring. Like that. Put our double bond here, like that. And I'm going to have one of those carbonyl methyl ketone pointing down, and I'm going to have the other one going up like this, like that. And of course, I'm going to have the enantiomer, where this one could be up and this one could be down. 6.42D, so 16.42D looks like this. So I've got this diene where I have a 5-membered ring. So that means automatically I know I'm going to form a a bicyclic product, which with a 5-membered ring and a 6-membered ring. Here's my dienophile, which is this compound called maleic anhydride. You don't need to know that. I'm just putting that in there. So we're going to form our 2 sigma bonds to make our 6-membered ring, and we're going to put a pi bond here. So let's draw the bicyclic product. Start with the skeleton, which has a sulfur in the ring up here. Here's our pi bond. Here's our 2 bonds to make our 6-membered ring. And of course, here we have the bicyclic product, but we're going to form the endo product. And so we're going to draw both of the bonds going down. And those are these 2 bonds that are going down to the carbonyls, which are locked in this 5-membered ring. So it looks something like this. Okay, and again, we have our protons. I'll put those in the exo position just for instructional purposes only. And I don't get an enantiomer here because this is a meso compound. Meso. There's a plane of symmetry through this molecule. Well, that covers all of those. Let's move on to question 16.43. And I find that question 16.43 is a question that students really like once they get the hang of the Diels-Alder mechanism, because actually drawing the starting materials can be actually a little bit quicker than drawing the products if you understand how to draw the curved arrows for the Diels-Alder, because it's the exact same arrows for drawing the retro Diels-Alder. So we just need to draw, essentially here we're drawing the retro Diels-Alder reaction. Retro Diels-Alder reaction. So we have our 3 curved arrows for our retro Diels-Alder. You see that we're breaking this sigma bond and this sigma bond. So that means that our dienophile, is going to look like this. We're going to have a double bond here, and we're going to have a carboxyl group here, and a carboxyl group here. So we end up with a Z or cis dienophile. And what's our diene going to look like? Again, we're breaking those 2 bonds that are highlighted in yellow. And so we're going to have a double bond here, and we're going to have a double bond here. And there you have it. Those are going to be the reactants that you would need to make that cyclohexene derivative. The next one is a little more interesting, isn't it? Because now we've got a bicyclic compound. But remember, the exact same rationale applies in terms of drawing the reaction arrows, the curved arrows. What are we going to do? We're going to draw our arrows in reverse. So let's take a look at those. So here is our 6-membered ring that was formed, right? You see the same thing here for the next one. And so you just draw your arrows in reverse. We're going to break this sigma bond, make our pi bond. We're going to break this sigma bond and make a pi bond. And we're going to take this pi bond and make another pi bond in our diene. So what are the reactants going to look like? Well, our dienophile is just going to be a carbon-carbon double bond, but you have every endo and exo position filled with a nitrile. So you're going to have 4 nitrile groups on it, and your diene is going to look like this. So we have a 6-membered ring, and we're going to have a double bond here and a double bond here. This compound, I'll just write the name over here. This is 1, so if you have 1, 2, 3, 4, this is 1, 3 cyclohexadiene, right? Earlier we saw 1, 4 cyclohexadiene. This is 1, 3 cyclohexadiene. Let's try the next one. Same rationale. You see we have the endo product here. Here's our 6-membered ring. We're going to draw our retro Diels-Alder arrows. We're forming our pi bond, breaking this sigma bond, making a pi bond here. Then we're going to make a new pi bond here. And so hopefully you see that our diene is going to be none other than cyclopentadiene. And our dienophile, since our 2 aldehyde groups are on the same face of the molecule, they're both in the endo position. We're starting with a Z or cis alkene, like this. And what about the last one? at the last one. So here we have another bicyclic compound here. And you can see that these two groups are in the endo position, are both locked in this ring. So we do our same retro Diels Alder arrows. We make a pi bond. We break this sigma bond, make a pi bond here. And what's our diene going to look like? We have a 5-membered ring with our 2 double bonds here. And then you probably remember this electrophile, or sorry, this dienophile, which is called maleic anhydride, which came up a couple of times today. And there you have it. Give me a thumbs up if you follow me on that, on how to draw the reactants that you would need to make these products via a Diels-Alder reaction. Great. Wonderful. Well, what I'd like to do now is take a look at some of those practice problems that I had posted. So I posted these to Canvas. It doesn't say fall 2020 on it. It says summer 22 on it now. Here we go. But I'd like to take some time to look at a few of these practice problems as a group.